Your 6.1 notes goes over properties of rational expressions and functions. The first part that we are going to look at is these rational expressions. So you have fractions that involve variables. With these, whenever you have a variable in the denominator, you have to state the domain. Your domain, when you have a variable in the denominator, is whatever your variable cannot equal. When we do these and find your domain, you will be representing them using interval notation. So if you remember from section like 1.1 and 1.2 from this year, that interval notation is going to come back, and you're going to be using that again. So if we look at example 1, we're told to find the domain for each rational expression. For example A, we're given x minus 2 over x plus 9. A lot of times it's a lot easier to put parentheses around each of your expressions, the one in the numerator and the one in the denominator, so that way you know that it's one specific term that x minus 2 is representing, and it's one specific term that x plus 9 is representing. So from here, we're going to take our denominator, which is the x plus 9, and we're going to set it to not be equal to 0. So the 9, you're going to move over by subtracting it from each side, and you just get that x cannot equal negative 9. Now, to put this into interval notation, you want the numbers from negative infinity all the way to positive infinity, not including the negative 9. So you're going to have a union, and you're going to go from negative infinity to negative 9 with a union of negative 9 to positive infinity. And you'll see here, if you remember your interval notation, that negative 9 gets the parentheses because it doesn't include the negative 9. For example, 1b, we're given y plus 2 over 5y. So again, I want to take that y plus 2 and put it in parentheses because I know I can't do anything else with that. It's representing one specific term. The 5y I can also put in parentheses. From here, I'm going to take the denominator since it has a variable, so that 5y, and I'm going to set it to not be equal to 0. We move the 5 over. It's being multiplied by that y right now, so we're going to divide each side by that 5. 0 divided by anything is 0, so we have that y cannot equal 0. In interval notation, we're going to have from negative infinity to 0 with a union of 0 to positive infinity. For example C, we are given x minus 3 over 2x squared minus 2. That numerator, that x minus 3, it is what it is. You can't do anything with it. The denominator, you can do this one of two ways. So you can just take the denominator and automatically set it to where it's not equal to 0 and solve for the x. Or you can see that you can factor in that denominator. So you can factor first and then set each part not equal to 0. It's totally up to you. You're going to get the same answer regardless. So if I used the denominator just as it is, the 2x squared minus 2 is not equal to 0, I would move the 2 over by adding it to both sides. So we get 2x squared is not equal to 2. Then we could divide each side by the 2. On the other side that's attached to the x squared, we get x squared cannot equal 1. And then we would just take the square root of both sides to get that x cannot equal. Remember, you're taking the square root of both sides, so you have to put that plus or minus in front of your answer. The square root of 1 is just 1. So your interval notation with this is going to be a little bit more trickier. You're going to have a combination here of unions. So from this, you have that x cannot equal negative 1. You have that x cannot equal positive 1. So from negative infinity, starting at negative infinity, we're going to go up to the lesser of the two numbers, which is negative 1. We're going to have a union from that lesser number to that higher number, so that's negative 1 to positive 1, with a union of positive 1 to positive infinity as well. So you want to represent every single number from negative infinity to positive infinity other than negative 1 and positive 1. For our next part of our lesson, we're just reducing each of these fractions to its lowest terms. If we look at example A, we're just given a regular fraction, no variables attached to it, anything. So you could do this one of two ways. You could find the greatest common factor between both the numerator and the denominator and divide each of them by that. However, if you didn't know what the greatest common factor between the 18 and the 42 is, you can tell that they're both even numbers, so they're both divisible by 2, and start by dividing 2. So if we were to divide each of these by 2, we are left with 9 over 21. Now think about 9, think about 21. What number goes into both of those other than 1? 3, so we would divide each of these by 3. So 9 divided by 3 is 3. 21 divided by 3 is 7. So that's just 3 over 7. If you knew off the top of your head that 6 was your greatest common factor, you could have divided the 18 and the 42 by 6 to begin with. It's totally up to you. There's no wrong way of doing this as long as it's completely simplified and in lowest terms. For example B, we're given negative 2a to the 7th power b all over a squared b cubed. Now, when I do these and I want to visually see all of my parts within my numerator and my denominator, I separate it into multiple fractions because I know that the entire term that's in my top, my numerator, is the same exact thing as saying negative 2 times a to the 7th power times b. In the bottom, I have a squared times b cubed. So I can write this as 3 fractions being multiplied by each other. It would just be negative 2 over 1 times a to the 7th over a squared times b, or b to the 1st, over b cubed. When I do this, I can visually see my like terms over each other, so it makes things a lot easier for me to simplify. Remember your rules of exponents. If you are dividing, you are subtracting your exponents. So that negative 2 divided by 1 is just negative 2. That a to the 7th power divided by a squared, you are going to subtract those powers. So it's going to be a to the 7th power minus the 2nd power. And that b to the 1st power divided by b cubed is going to be b to the 1st minus the 3rd power. If we simplify our powers here, we're going to have negative 2 times a to the 5th power times b to the negative 2nd power. Remember, we cannot have negative powers in our solutions, so we're going to take the reciprocal of that b to the negative 2nd power and have negative 2 times a to the 5th power over 1 times 1 over b squared. So if I put all of this together as one fraction, I'm going to have negative 2a to the 5th power over b squared. Now, do you have to do all of this with every single step that I just did? No, you don't. If you can see your like terms on top of one another in your fraction that you started with and know, okay, I have a to the 7th on the top, b squared on the bottom, my bigger powers on the top, I'm subtracting them, that 5 is going to stay on top, you could do that. If you see your b terms, your bigger powers on the bottom, I'm subtracting them, I'm doing 3 minus 1, that 2 is going to stay on the bottom, that b squared is going to stay on the bottom. You can also do that. You do not have to do all of these steps just to get this answer. Another way to reduce these rational expressions to lowest terms is looking at your expressions or your fractions that have variable expressions included in them. If we look at example A, we're given 2x squared minus 18 all over x squared plus x minus 6. So now you have to think about factoring. If you look at the top, the numerator, you have 2x squared minus 18. You have a greatest common factor of 2 there. So you can factor out the 2. You'd have 2 times x squared minus 9. On the bottom, that's 6. You have factors of 2 and 3. If the 3 is positive and the 2 is negative, we get a 1. So that factors out to be x minus 2 times x plus 3. Now, in the top, you still have a difference of squares. So you can take the square root of the x squared. You can take the square root of the 9. you have the subtraction in between the two terms. So this is going to be 2 times x minus 3 times x plus 3 all over x minus 2 times x plus 3. From here, you're going to cancel out any like factor. Remember, what's in parentheses is an entire term that's being represented. So it's representing one single number. If we see here on the top, we have x plus 3. On the bottom, we have x plus 3. So this x plus 3 is going to cancel out from each of these, and you're just going to have 2 times x minus 3 over x minus 2. This will be your answer. However, you do have an extra part to these. You have a variable in your denominator. There is an expression in your denominator that includes a variable. So you have to find the domain. You have to give what x cannot equal. Once you factor your denominator, set each part not equal to 0, and solve for the x. If we move the 2 over, we add it to each side, we get that x cannot equal 2. If we move the 3 over, we subtract it from each side, we get x cannot equal negative 3. So using your interval notation, your smaller number is the negative 3, your larger is the 2. So we're going to go from negative infinity up to negative 3. Don't include the negative 3. With a union of negative 3, not including negative 3, up to 2, not including the 2. With a union from 2, not including the 2, up to positive infinity. So that is part of your answer, that domain. In example B, we have w minus 2 over 2 minus w. You see your denominator is 2 minus w. If we rearrange the terms here, this is giving us w minus 2 over negative w plus 2. Your denominator has opposite signs than your numerator. So if we factor out a negative, our numerator and our denominator are going to be the same. So we're going to have w minus 2 over a negative times w minus 2. You're completely factored in your denominator right now, so set that not equal to 0. We move the 2 over by adding it to each side, and you get that w cannot equal 2. Now, this w minus 2 is on the top and the bottom, so they cancel out, and we just have 1 over negative 1, which is negative 1. And again, your domain is that w cannot equal 2, so we're going to have from negative infinity up to 2, not including the 2, with a union of 2 to positive infinity, not including the 2. For example C, we're given 2a cubed minus 16 over 16 minus 4a squared. So I'm going to do this by rearranging my bottom terms first. So I'm going to have 2a cubed minus 16 over negative 4a squared plus 16. I'm going to factor the top and the bottom here. We're going to factor out the greatest common factor from both of them first. So this is going to give us 2 times a cubed minus 8 over negative 4 times a squared minus 4. I have a difference of cubes on the top. We have a difference of squares on the bottom. So this then simplifies to be 2 times a minus 2 times a squared plus 2a plus 4 over 4 times a minus 2 times a plus 2, because at the bottom we have a difference of squares. From here, we have a variable in the denominator, and we are completely factored. So we're going to take the variables terms in the denominator, which is a minus 2, and set it not equal to 0, as well as a plus 2, and set it not equal to 0. We move the 2's over for each of these, and we get that A cannot equal positive 2, and A cannot equal negative 2. So we're going to have a domain here from negative infinity to negative 2, with a union from negative 2 to positive 2, with a union of positive 2 to positive infinity. So that's part of our answer. I'm going to highlight this now so I don't forget about it. And then I'm going to cancel out with that factored fraction. So on the top we have a 2. This bottom should be negative 4. 2 and negative 4 have a common factor of 2. So we can divide both of these by 2. The top's going to become a 1. The bottom's going to become a negative 2. The negative never stays on the bottom, so bring it up top. So we're going to have a negative 1 over negative 2, or sorry, over positive 2. On the top, you have an a minus 2. That cancels out with the a minus 2 on the bottom. On the top, you still have the a squared plus 2a plus 4. On the bottom, you still have the a plus 2. So this would be our solution. So we're going to have negative 1, or negative, times a squared plus 2a plus 4 all over 2 times a plus 2. All right, so with example 4, you're just converting each rational expression to have the indicated denominator. So with these, we start off easy, we get a little bit harder. With A, you're given 2/7 is equal to something over 42. Ask yourself, 7 times what is 42? Well, 7 times 6 is 42. So if we multiply this 2 by 6, we get 12 over 42. For example B, we're given 5 over 3a squared b is equal to something over 9a cubed b to the 4th power. For this one, it's going to be a lot easier if you divide your two denominators to see what you're multiplying that 3a squared b by. You could do that, or you can tell yourself 3 times 3 is 9, so it's going to be a 3. Then a squared times what is a cubed? That's a. And b times b to the what power is b to the 4th power. That would be b cubed. So again, you could do this by dividing the 2. So if you had 9a cubed, b to the 4th, divided by 3a squared b, you're still getting 3ab cubed. We're going to multiply that by 5. In order to get that question mark. So 5 times 3 is 15. Keep the a, keep the b cubed. And that would just be over 9a cubed b to the 4th. For example 5, we're doing the same exact thing. With these, again, what we did with that last question, you may be better off doing with the two denominators here, so that way you can get exactly what you have to multiply the top by. If we look at example 5a, we're given 5 over 2a minus 2b is equal to something over 6b minus 6a. Now that 6b minus 6a is not in the same order as that 2a minus 2b, so I would rewrite that to be negative 6a plus 6b. From here, I can factor, or I can just divide that by the 2a minus 2b. If I factored both the numerator and the denominator, I'm going to have a negative 6 times a minus b over 2 times a minus b. These a minus b's would cancel, and negative 6 divided by 2 is negative 3. So if I just multiply that 5 by negative 3, we get the negative 15 that we're looking for over 6b minus 6a. For example B, you're given x plus 2 over x plus 3 is equal to something over x squared plus 7x plus 12. Now, we are going to put parentheses around the x plus 2 as well as around the x plus 3 and factor out the x squared plus 7x plus 12. The factors of 12 that add up to be 7 are 3 and 4. So we can rewrite this as x plus 2 over x plus 3 is equal to something over x plus 3 times x plus 4. So what does the second denominator have that the first does not? The x plus 4. So multiply the top, that x plus 2 by x plus 4. So we're going to have x plus 2 times x plus 4. This gives us x squared plus 6x plus 8. And we're going to put that over x squared plus 6x plus 8 goes over x squared plus 7x plus 12. If we look at our last example, we are taking a function that's given to us and substituting in for the variable. So we are told to find the domain of the function r of x is equal to 3x minus 1 over x squared minus 4. Then find r of 3, r of negative 1, and r of 2. To find the domain first, remember, take the denominator, set it to be not equal to 0. So to find the denominator, we're going to take x squared minus 4, set it to where it's not equal to 0. We're going to move that 4 over by adding it to each side. We get x squared cannot equal 4. We take the square root of both sides. And x cannot equal plus or minus 2. In interval notation, our domain is from negative infinity up to negative 2, with a union from negative 2 to positive 2, with a union of positive 2 to positive infinity. From here, we're going to find r of 3, r of negative 1, and r of 2. To find r of 3, we're going to have 3 times 3 minus 1 all over 3 squared minus 4. The 3 times 3 is 9 minus 1 over 3 squared is 9 minus 4. 9 minus 1 is 8. 9 minus 4 is 5. So r of 3 is 8/5. For r of negative 1, we're going to have 3 times negative 1 minus 1 over negative 1 squared minus 4. The 3 times negative 1 is negative 3 minus 1 over 1 squared. Negative 1 squared is 1 minus 4. So this is going to give us negative 3 minus 1 is negative 4 over 1 minus 4 is negative 3. These will turn into positives, and r of negative 1 is 4 over 3. For r of 2, you could do this one of two ways. You can either realize that your domain is that x cannot equal positive 2 or negative 2, so this is going to give you no solution, or you can simplify it. If you did r of 2 is equal to 3 times 2 minus 1 over 2 squared minus 4, this is going to give us 6 minus 1 over 4 minus 4. The 6 minus 1 is 5. 4 minus 4 is 0. Anything over 0 is undefined. So we do not have a solution for that one.